Hello, class. This is your teacher, Mrs. Bassett, and today we are going to go over adding, subtracting, dividing, and multiplying properties in a one-step equation and also in tables. We have a few goals that we're going to set in this mini lesson, such as identify an additive and multiplicative relationship in an equation and expression, identify additive and multiplicative relationships in a table. We're also going to solve one-step equations using addition, subtraction, multiplication, and division. And we have some TEKS that are expected of you to learn. You are to compare two rules verbally, numerically, graphically, and symbolically in the form of y equals a multiplied by x or y equals x plus a in order to differentiate between addition and multiplication relationships. You also are expected to represent a given situation using verbal descriptions, tables, and graphs, and equations in the form of y equals k multiplied by x or y equals x plus b. Now, why are we going over this? Well, the purpose is to identify in an expression, equation, or table whether there is an additive or multiplicative relationship. I also want you to solve for the unknown, the x, or variable, by determining if addition, subtraction, multiplication, or division is needed. Now, I want you to write down these questions on your own piece of paper at home. I want you to answer each question, and then I want you to have it ready to turn in tomorrow at the start of class. Answer them the best of your knowledge of how I've explained it. And of course, if you have any questions, put your questions at the end. So label 1 through 7, and at the very end, write your questions that you have and bring them to class, ready to be answered. We're going to start off with some definitions. A variable is a symbol, such as a letter that represents an unknown number. For example, you could think x is a variable, y is a variable, a is a variable, z is a variable. Next is proportional. I'm sure you've heard me say proportional before. It is simply having the same or constant ratio, and that'll make more sense later. Now we have two relationships. The multiply relationship is that you multiply any x value by the same number to get the corresponding y value. If it's not the same number every time, it is not multiplicative. Division can be a multiplicative relationship because dividing by a number is the same as multiplying by its reciprocal, and that's an important word too. The additive relationship means you add the same number to any x value to get the corresponding y value. If it's not the same number every time, it's not an additive relationship. Subtraction can be an additive relationship because subtracting a number is the same as adding a negative number. Now we have some examples. What would you think of this? Is this proportional? 6 equals 6. Well, I'm sure you've seen that. If you've got 6 of something and then 6 of something on the other side, yes, of course it is equal. What about this? If we, what if you don't have numbers? You just have shapes. Does 4 equal 3? No. What about this one? Does this make sense? Does 2 plus 4 equal 6? Well, yes it does. What if we add these numbers? 3 plus 9, does this equal 11? No, it equals 12, so this is not proportional. Substituting a number for a variable. Oh, what if we don't know what this is? What is x? There's many ways that you could be thinking of this. Maybe you already know from the past examples that we know that x is 4. I want you to answer this on your guided notes. Give your best answer. What is x? And do a brief explanation on how you would solve this. Next, we have some examples. So first we have 8y equals 48. A key thing to remember is what is going on right here between this y and this 8. What's going on? Multiplication. What is the inverse operation? The inverse operation would be basically its opposite. The opposite of multiplication would be division. So we simply just divide by this same number, and this becomes 1. And 1y is the same thing as just y. So these would cancel, but what we do to one side, we must do to the other. And what is 48 divided by 8? I think you guessed it. It is 6. And that's our answer. Our next example is probably a little easier, is q minus 12 equals 1. Again, you're going to hear it a lot. What is the inverse operation of subtraction? Yes, it is addition. So what we do to one side, now what we're trying to do here is make this 0. And is 12 subtracting 12? Yes, that is a 0. So it really just gets canceled. But what we do to one side, we must do to the other side. Since this side is out, we need to add this side. Of course, is 13, giving our answer that we know q is 13. Now, given both of these, how do you know it's right? What if you second guess yourself? Well, that's why you need to check your answer. So if we say y is 6, can we say 8 multiplied by 6 is 48? Yes, we can say that. Can we say that 13 in the place of the q, making 13 minus 12, is that 1? Yes, it is. Now we have another example. 18 equals a over 2. And what's going on right here? Division, yes. And if up here the inverse operation was division for multiplication, the inverse for division would, of course, be multiplication. Now watch where I put the 2. I did not drop it below because I wanted to show you that 2 here, that is basically a big 1. And just like from here, 1y is really just y. So here we've got to do it to the other side. So here you could say 36 equals 1a, or 36 really just equals a. And this is perfectly okay to have an integer on one side and a variable on the other. Because up here you see we have a variable on one side and an integer on the other. And they can be switched. And last, I'm sure y'all are getting to be experts now. And The operation that's being done now is addition. If the inverse for subtraction was addition, our inverse for addition will be subtraction. So here we are going to subtract a 1, because 1 minus 1 is going to give us a 0. And what we do to one side, you must do to the other, making S be 2. Can we check our answer? Yes. If S is 2, 1 plus 2 does equal 3. Check. So, a proportion is like a balancing scale. You must have the same weight on each side of the scale to be equal, just like when we solved an equation or an expression. Now, I would like you to go to this Edpuzzle. I will be getting on to make sure that everybody has completed it. All right, so what if you were given a table of either y equals kx or y equals k plus x? The k is the constant of proportionality. Whoa, big words, right? That's just saying a constant, and a constant is really just a number that never changes in the equation, such as this 4, unless combined with like terms. So say I had a 4x plus an x. Well, you'd have to combine them, and it would be a 5x. X is a variable that can be substituted for a number, and the y is our output once the variable has been substituted for a number. So I have this table. We have when x is 1, 2, 3, or 4, this is our output of what the outcome is. So here's our little equation for x. So here I've got an x of 1. That means I'm substituting 1 in for x. Of course, 4 times 1 is 4. With this one, 4 multiplied by 2 is 8. 4 multiplied by 3, right here, is 12. And lastly, 4 multiplied by 4 is 16. This is the y. However, what if we have some missing components? What should we do? First, substitute the information into the equation. So here, I've got my original equation. I know what it is. So what do I have? I have y is 4, so I can substitute 4. And what did we learn with our one-step equations? We want to get x by itself. So of course, what we would do is do the inverse operation of dividing 4 on both sides. And what would this give us? Of course, a 1. 4 divided by 4 is 1. Well, we know what the next one is. We know what this is already, because yes, 4 multiplied by 2 is 8. Oh, but this next one, we do not know what it is. So of course, with our one-step equation, we can simply just multiply. So we know that 4 multiplied by 3 is 12. So you substitute the information into the equation. Decide what the inverse operation should be. Solve by performing the operation chosen. Last, you need to check your answer. That's the for sure way. All right, tomorrow in class, please bring your guided notes with you to class and turn them into the appropriate bin. You may include questions you still have. We will elaborate more on using tables to solve one-step equations. I will be checking for completion on the Edpuzzle, so make sure you have completed it. And tomorrow we'll be playing a one-step game. So be prepared to be paired off and use those competition skills. Please watch the Edpuzzle video and this video as many times as you need to understand the concepts. Thank you so much, and I look forward to seeing you in class tomorrow.